I'm now going to go through an example. And so you do this example, I downloaded two data sets that are currently posted in the New York Times COVID data repository. So one of the data sets I downloaded, I've named here M, and it's mask used by county. So I can show you what kinds of things that data set includes. So these are county labels. And then what it is they did a survey, and they did the survey at, I think, the end of July 2020. And they used that survey to try to estimate the proportion of people who always wear masks frequently, sometimes rarely, never wear masks within each county. It's worth mentioning that, they did some adjustments because they were concerned about generalizability. So for example, they knew from the census how many people should be in each age group, so in their, in their teens, in their 20s, in their 30s, 40s, etc., within each county. They knew that from the census data, and so they took their survey results and they tried to adjust them. So for example, if most of the people in their data set were teenagers, they said, well, wait a second, we have to downweight those teenagers and upweight people in the other age groups because I can see from the census that this county is not only teenagers. So these are the results of again, survey data that has been adjusted to try to do a better job with generalizability. So for each county, we have these estimates. That's one data set. The other data set I'm going to use, I called it D, is from the live US county data that's available via the New York Times. And what that does is for each day, this is from September 7th, 2020, they are showing us every county in the US. Here's the code. Note that it's the same code. It's got a different column name, but this county FP has the same information in it as FIPS. Okay, it's the FIPS code. And they show us how many cumulative cases there have been in that county so far. Usually this is since January. How many deaths, how many confirmed cases, confirmed deaths, probable cases, probable deaths. Okay, and they have these, and this particular data set only contains data from September 7th, 2020, and I checked that by saying, well, wait a second. If I make a table of how many times each county appears in this data set, right? There's a lot of different counties. What's the maximum number of times a county appeared? And the answer was 1. That tells me there's no county that appears in here twice. So this is really county data, which is good to know. So what I decided to do was look at the always column. In other words, across all these counties, what proportion of people say that they always wear a mask? Okay, so here's a picture of that on this always column. And I skipped a step that I merged together these two data sets. We'll talk more about merging later, but you can see it here. I used the word merge. And so I merged those two data sets because they had the same county labels. I was able to do that. And for the purpose of this exercise, I just threw out the counties that didn't appear in both because both of these data sets are meant to include all counties. And so when there isn't one, it's a little bit of messy data, like somehow the county name is unknown. It probably isn't really a county. So that's what I have here. Okay, so among the counties that are in the final merged data set, that it contains both data about masks and data about cases of COVID, here is a histogram showing the distribution of proportion of people always wearing their masks. And you can see it varies a lot. Okay, it varies enormously. And so what I decided to do was split this up into two groups with a cutoff at 0.5. That was arbitrary. That's what I decided to do because what we're talking about right now is t-tests. And so I want to have an example I can show you where there are two groups. So I'm going to split the counties up into two groups based on the counties where more than 50% of people say that they always wear their masks, and counties where fewer than 50% of people say that they always wear their masks. And so that's what I'm going to do, and I can make a table. So here I'm making that variable, and here I'm making a table of this new variable. So 1 means that always was greater than 0.5. So there are 1,533 counties where more than 50% of people say they always wear their masks. And there are 1,587 counties where fewer than 0.5 people say they always wear their masks as of the end of July 2020. Okay. So now what's my measure going to be? Here I decided to use cases. So let me just summarize the case variable. So here is number of cases, okay, of COVID. This is cumulative. So as of September 7th, how many cases have there been since January 1st, 2020? You can see this varies a lot. Some counties have 1. And then some counties have a huge number. And actually, I think I did this, but I didn't keep it here. I was interested. Let's see, what I wanted to see was the county names where the case levels were like enormous. because I was wondering if there's a typo. The first thing you should think when you see some gigantic outliers, whether there's just a mistake. So I did that. That must not be the name of the county variable. The name of the county variable is county lowercase. Okay. Okay, so here are the names of the counties where the cases are more than 100,000. So looking at this, actually, I believe it, because Los Angeles is huge, right? And California has had a lot of COVID cases. Miami-Dade in Florida, right? They've had a lot of cases. I don't recognize necessarily the other ones, but I am willing to believe that actually there are 5 counties in the US that are just big counties in places that have had a lot of problems with COVID. And those are really the counties that have a lot of cases. So I think it's probably not an outlier that is a mistake. I think it's probably a real outlier. And so we will keep those values in. So then the next thing I did is I said, I want to look at a box plot of the number of cases in each county by whether the proportion of people who always wear masks is above or below 0.5. This is not the only way we could use these variables. This is just how I decided to do it today. Okay. So here's my picture. Now, what do we see? What we see is these look really squished. These box plots are really squished because there's just so many huge values. So here, these counties we're looking at with the enormous values, because the axis has to be stretched enough to fit those enormous values, we actually can't see any of the other values. So what do we do here? We cannot just throw out those values. They're real and they are part of the data set and they are actually happening. So what I'm going to do is I'm going to take the log. Now, you may not at this point have watched the lecture about logs, but all you need to know at this moment is the variable I'm going to choose as my outcome variable is not number of cases, but rather log number of cases. If logs are something you haven't thought about in a really long time, do a little Googling, remind yourself what a log is. The thing, and I'm happy to help as well, of course, the thing to know is that in R, it's always log base E. Remember, E is the number 2.71. And in statistics, in R and statistics, the default is to use log base E. In R, you can change that default if you want to. But again, in statistics, the log is log base E, and in math class in high school, you may have written that as ln. When we say log in statistics class, we mean ln. Okay, so all you have to know right now is my variable of interest is just going to be the log. Why? Well, because look, that's so much better, right? When I log this variable, the largest values are pulled in. This is stretched out. These now look nice and symmetric. This is now going to be possible to deal with using the methods that we've been discussing recently that are not necessarily robust to outliers and that do better if we have some sort of symmetrical data set here that's just a little bit more normal looking. So here's the box plots. So, okay, we have the counties with more masks and the counties with fewer masks in terms of, or more people wearing masks, fewer people wearing masks. Okay. And we know that we have about more than 1,500 counties here and more than 1,500 counties here. With those 2 pieces of information alone, I can tell you that the p-value here when we run a test is going to be 0. And that's intuition that I want you to start to build as well. Look at this. The medians are pretty far apart, right? The medians are pretty far apart, and I know the sample sizes are enormous. When you have so much data and you can see from the picture that the box plots are in different places, or equivalently, when you can see from the picture that the histograms are centered in different places, if you know the sample size is really large, then you know you have evidence, enough evidence to rule out the possibility that actually we have the same proportion of people always wearing masks in counties that have, sorry, let me say that correctly. We definitely have enough data to rule out the possibility that the average number of cases is the same among counties where more people wear masks and versus counties where fewer people wear masks. So one thing I think it's important to comment on right here is that although I can see the result from the picture, this is not causal. So we don't get to say that wearing masks prevents COVID or causes COVID, looking at these pictures. Now, I bet most of you would believe me that wearing masks does not cause COVID, but look, there's more COVID cases in places that wear masks. Why is that? Well, probably because there are mask laws or people are more afraid of COVID and realize they should wear masks in places that have more cases. Note also that the survey about masks was done in July, but the COVID data comes from January through September. So just because we see a correlation here doesn't mean that you should use this data to say, hey, wearing masks causes COVID, right? You know that, but I'm just reminding you of that. So we're looking at this, and what I want to do is I want to do a t-test. And looking at these histograms and also the box plots previously, I need to decide whether I'm going to do a pooled t-test or not. Now, what I usually do is literally, if it's a box plot, I literally take my thumb, and here I can kind of take my mouse and say, is the width of this about the same? Sure, the width of these are kind of the same. Or if I go back to the box plot, oops. Let's get that back so it's just one picture at a time. Okay. You can't see my thumb, but if I take my thumb is actually just about the width of each of these boxes, and they're about the same as each other. Okay, so I'm going to make a decision to use the pooled t-test here. I'm going to pause right now, and I want you to just quickly write down for me, what are the assumptions of a pooled t-test?